Okay, today we're going to talk about arc length, and that's different than arc measure because arc measure was talking about the degrees of an arc, where the arc length is going to be asking us to find the portion of the circumference. So before we do that, first let's remind ourselves the relationship between the central angle and the measure of the arc. Well, they are the same. So remember, central angle was that angle that had the center as a vertex, and that was the same measure as the arc. Now this stuff down here, if we were doing this in class, I would have you guys work through this to kind of think about the formula, but that's kind of hard to do in this video. So we're just going to go right down here to talk about the actual formula, and we're going to spend some time here. So this is a formula for the arc length. And you may recognize that this part is the circumference. So that's the circumference. And if we look at our picture over here, the arc length, I only want to calculate the distance or the length from A to B. I don't want the whole circumference. Remember, circumference is the distance around the whole circle. So this blue line would be my circumference, but I don't want that. I just want this part here, this fraction of it. And since the whole circle is 360 degrees, what I'm going to do is I'm going to take my central angle, this angle right here, and divide it by the whole circle, which is 360 degrees. And that's where this part comes from. I take x, which is my central angle, and we have that up here. X is a measure of the central angle. And I divide that by 360, and then multiply that by the circumference, because I only want, I only want this part of the circumference, this arc. I don't want the whole thing. I just want the distance from A to B. So that's why I multiply it by the fraction x over 360. So let's look at some examples. So find the indicated measures. So we want the length of AB. So I want to figure out what this distance is. So the arc length, I just kind of write it as a cursive L, is equal to x over 360, or our angle is 88 over 360 times 2 pi times our radius, which is 2. Okay, so now you may be thinking, well, how am I going to type all this into the calculator? So I'll show you. Let's open up our calculators. And in parentheses, I'm going to do 88 divided by 360. Close the parentheses, times 2 times pi times the radius in this problem, which is 2. There should be a 2 right here. So then our circumference, or sorry, the arc length is going to be 3.07. 3.07 meters. Okay, example B. We're trying to find the arc measure this time. We're given the arc length of 38. So in our formula, remember this is our formula, we have the length. We have the arc length is 38. So let's plug that in. We don't know what x is. We have 2 pi and the radius is 12.3. Now what we can do is to solve this a little bit faster. Let's remember that this is really over 1. And when we multiply fractions, we can multiply straight across. So I'm going to multiply the whole top together. So then it's going to be 38 equals, and when I type all that into the calculator, okay, 2 times pi times 12.3, we get 77.28. So 77.28x over 360. Now, yes, from this point you could multiply both sides by 360 and then divide by 77.28. But since we're already using our calculators, let's just simplify this part right here. Let's do 77.28 divided by 360. 77.28 divided by 360. We get 0.2146 repeated, but let's just use 0.21. So this leaves us with 38 equals 0.21x. Well, then from here, just divide both sides by 0.21. So 38 divided by 0.21. And we get 180.95. So x equals 180.95 degrees. Now you may be saying, well, 180 is over half a circle, and this is clearly, this arc is clearly not half the circle. Well, again, that is why you don't always go by what the picture looks like. You go by the math. Alright, I'm going to go down and do letter D, and then after that one, I'm going to have you try letter C. So letter D, we're going to try to find the circumference. Well, the reason why I like to use this arc length formula is because the circumference is already here. It's right there. So as soon as we get that part by itself, we're done with the problem. We don't have to find the radius. That's not what we're asked to do. So let's plug in what we know. We know that the arc length is 3.44 equals, we know the angle is 60, and then we have 2 pi r. Now, what I'm going to do is I'm going to simplify this fraction here. 60 over 360. That simplifies to 1/6. So we have 3.44 equals 1/6 times 2 pi r. Well, if we multiply both sides by 6, that gets rid of the 6 is there, and then on the right side we're just left with 2 pi r. So then in my calculator, I'm going to do 6 times 3.44, and that gives me 20.64. So 20.64 equals 2 pi r. Well, 2 pi r is this formula for circumference, so we are done. That is our answer. And that only works because this formula right here is our circumference formula. So again, that's why I like using the arc length formula that I provided. Other teachers may have different ways of doing it. So looking at letter C, that one is just like letter A up here. So pause the video, try it, and once you're done, unpause it and see if we got the same answer. Alright, hopefully you got 6.77 feet. If you got something around that, that's fine. It could have just been a rounding issue. So just make sure that you're using 2 decimal places when you round. Alright, let's look at the next page. This one example is a good mixture of arc measure and arc length. Remember, arc measure is going to talk about the angle. So this the answer is going to be in degrees. Up here we have that angle ADC and angle BDC are congruent. So ADC and BDC. So these two angles are congruent. So we can figure out what those two angles are before we start the problem. And we can do that by saying, all right, 360 minus the 101 that we know. So if we type that into our calculators, we get 259. And since those two angles have to be the same, we can do 259 divided by 2. And we get 129.5. So each of these angles is 129.5 degrees. So now what we're going to do is we're going to find the arc measure of ACB. That's talking about going from A to C to B. We're not trying to find the length, we're trying to find the arc measure. So we want to find what do these two angles add up to. Well, and we've already done that right here, 259. So that is the arc measure, 259 degrees. And in letter B, we just want to know the arc measure from C to B. This part right here, the measure of it. So that angle we've already calculated is 129.5 degrees. Now letters C and D, we're asked to find the length. That's where we use the arc length formula. And I will let you do those real quick. So pause the video and do that. You have the angles right above the problem. So your x for this problem is right above it. So take a second or two to pause the video and see if you can get these answers correct. Okay, so those are the answers I got, so check yours to make sure that you got the same thing. And again, make sure you're rounding with 2 decimal places. All right, now the letters E and F, E's asking for the arc measure of ABC. So if we go back up to our picture, I'm going to erase these. ABC is this right here. So the arc measure is going to be 101 plus 129.5. So if we type that into the calculator, I get 230.5. And then letter F, the length of arc BAC. So again, if we see the word length, that's how we know we're going to use the arc length formula. So BAC is this right here. So that arc measure is going to be 101 plus 129.5. So my angle, or my x value, is going to be 230.5. So over 360 times 2 pi times the radius, which is 24.9. So again, we type all that into the calculator, and that will give us the arc length of that. So if we type that in, we get 100.17. And our units were meters. All right, let's look at the next page. So this is from Calvin and Hobbes, my favorite comic of all time. And what they're talking about here, you have the notes, so you can read it. What they're saying is that, if I pick a point here and a point here, that, this dot, the green one, has a much larger circle to go around than the blue one. But, these two always stay together. So that means that the green dot must be traveling faster than the blue dot, even though they're part of the same record, because this record will spin around and around, and that's how the music gets played. So the green dot is moving at a faster rate than that blue dot, even though they're part of the same record. So that's what the comic book was saying, and it clearly has disturbed poor Calvin here. So we're going to use this to solve letter A. So it says in one revolution, how much further does a point 10 centimeters from the center of the record travel than a point 3 centimeters from the circle? So we need to find the circumference of 10 centimeters from the center, because that would be our radius, and 3 centimeters, that would be the radius of the smaller one. So circumference equals 2 pi times 3. Circumference is 6 pi, and I'm going to leave pi there for a minute. And then for the blue one, the circumference equals 2 pi times 10. So the circumference is 20 pi. So the difference between those two, 20 pi minus 6 pi, is 14 pi. And if we type that into our calculator, we get 43.98 centimeters. So that's how much further that dot has to go that's further away from the center of the record. So yeah, that didn't really have anything to do with arc length, but I just thought it was kind of interesting to have that there. And we're not going to do letter B. Actually, it'll probably be erased on yours. So the main ideas here was really this formula. Know how to use this formula in all the ways possible. So